I'll do that. Question number 49. We are trying to do question number 49 now. Figure shows a vertical cross-section of a shallow circular pond covered with a thick glass plate of thickness 4 centimeter and refractive index 3/2. The ponds contain water up to a lower surface of the glass plate and a point source of light is placed at the bottom of the pond as shown. Depth of water in the pond is 30 centimeter, and refractive index of water is 4/3. 4/3. Right. Okay. These are the they provided you all. Question number. We have a light source which is at the bottom. This is 30 centimeter according to the question. This is 4 centimeter. 4 centimeter. Glass, water. A person, when looking at the pond from the above, see the circular patch of light. Explain briefly how a circular patch of light is formed. So I did this part under the application, but when it comes to a question, you should understand how to write your answer, how to write your own answer. Look at this. Make it කියන්න මේ වගේ දෙයක් නේ. මේ උඩින් බැලුවොතින් කෙනෙක්ට පේන්නේ මේකේ circular light patch එකක්ලු ඒක වෙන්නේ කොහොමද කියලා යහන්නේ. එතකොට ළමයි දැනගන්න ඕන කොහොමද මේ වගේ එකට answer එකක් දෙන්න කියලා. Look at here. So I can draw a ray which is go through this line. What will happen based on the refractive index values according to the question? This is what refractive index of water is given as 4/3. Refractive index of water is given as 4/3. In W, this is in glass, which is 3/2. Right? This glass is dense medium compared with water. The reason is how I know that, how I knew that, based on the refractive index values. Refractive index of this 3/2 is greater than 4/3. We know that higher the refractive index, higher the refractive index, that is the lens median. So in here it bends towards the normal, At this point it bends away from the normal. So if I take another ray, it again bends towards the normal. But what will happen at this location? It might be a location of critical or the total internal reflection point. It might be the critical angle here. Because for the glass and air is a rare medium compared with glass. So there is always deviation angle. Bends away from the normal. So in a situation like this, it can be the 90 degrees or it is a critical angle. If it is a critical angle, this must be critical angle. Like that, if you consider other way also, other direction also, we get the same feeling. So finally, we could see something like this on the glass patch. It's a light beam. It's a light patch. Beyond that, what will happen? It won't come to the AR medium, it is reflected back. Beyond that, let's say we have something like that, it is bends towards the normal. But this particular angle is more than the critical angle, it bends again, it comes to the same medium again, because it's totally the reflection. So if you draw the things like this, that is totally accepted, that is enough for the exam. But for to complete the content, we will write something. We will write something on that. Understood නේද මේක? මේ වටේම මට අඳින්න පුළුවන්. එතකොට මේ වගේ light patch එකක් දකින්න පුළුවන්. Right under that. All the light rays, which are less than the critical angle, enter the air medium through the glass slab. Enter the air medium through the glass slab. Through the glass slab. If the angle of incidence more than the critical angle for glass air interface, reflected back to the glass medium, Therefore, we get circular light patch. Circular light patch on the glass surface. Right, I think everyone could understand. Let's move to part number two. Using only standard laws of refraction and geometry, calculate the radius of the circular light patch seen on the glass plate. So they want us to calculate the radius of this. They want us to calculate the radius of this. Okay. So how to calculate? So I should think about the critical angle point. Critical angle. Margin critical angle point එක තමයි මම හිතන්න ඕනේ. එතනට වඩා වැඩි වුණොත් ඉතින් අනිවාර්යයෙන්ම මේ පැත්තට එනවා. අතන මේක තමයි margin එක. මේක හිතලා තමයි කරන්න ඕනේ. Right? For the part B, part 2. Bends towards the normal, this is 90. Water equal 4/3. This is glass. In glass equal 3/2. This is the critical angle C. This must be C then based on the simple geometry. Let's say this is I. This is I. This is AR medium, which is 1. So I need to find the R value. I need to find the R value. Let's say this is X. Let's say this is Y. So the radius of that light patch equal radius of the light patch. Radius of the light patch equal R. R is equal to X plus 1. So it is our duty to find X separately, Y separately. Apart from this, they have given you this has 30 centimeter and this has 4 centimeter. 4 centimeter. Right. So how to find that? We know this. So if we know that, we can find that value. If I know the value of C, critical angle, let's find it first. Let's find it first. Sin C over sin 90. Sin C over sin 90 equal 1 and 2. In this particular case, it is glass in air. So look at here, how did I write this one? Always I'm using this 1 into glass 1 because started from this medium, then it come to that glass in air. Are you clear with this? So always remember the way that I did the question. Sin C equal sin 90 is 1, NA over NG. Sin C equal 1 divided by glass. NG 3 by 2, it is 3 by 2, 0.666 something. So C, can one of you tell me the value of C? Any one of you? What's the value of C? Anyone? Can you please find that value? (41 degrees). 41 degrees and 48 minutes. Okay. Right. I found that value. So I try to find the X value. Tan C equal X divided by 4 centimeter. 4 centimeter. Tan 41 degrees, 48 minutes. X divided by 4. What's the value of this? Anyone who have calculated this? So don't give up, try yourself. 0.894. So that means X equal 0.894 into 4 centimeter. So when you simplify, you would get a value like 3.58. 3.58 centimeter. We found the X value. In the similar way, we have to find Y. To find Y, I should find I value. This is I. If this is I, this must be I. Let's find sin I. To find sin I can apply the Snell's law at the interface of water and glass. Sin I over sin C equal 1 and 2. In this case, it is water in glass. In glass over NW. Find C. Find I, sorry. I. Find C. NW, NG over NW. NG means 3 divided by 2, 4 divided by 3. Find C. Find C, we know that it is 2 by 3. Ne? So I use this one, 2 by 3, 3 by 2, 4 by 3, like that. 3, 3, 2 cancel. Find I equal 0.75. 0.75. Then I equal how much? I equal how much? Yes, 48 degrees 35 minutes. Good. You all are getting the answer. Good. 48 degrees and 35 minutes. Then if I know the I can calculate the Y value because based on the tan I. Tan I equal Y divided by 30. Ne? So the Y equal 30 into tan 48, 35 minutes. 30 into tan 35. Any one of you? Tan 48, tan 35. What's the value? 0.7002, which is how much when I simplify? Like 34.01. 30. No. I think 48 degrees and 35, it is more than that value. Eh? Yes. 1.1363. 1.1363. 1.1363. The reason is tan 45 is 1.1363. 1363. So then it becomes 34 something. 34.01. Y equal that centimeter. Now we can find the radius. R equal, I use this space. R equal x 3.58 plus y equal 34.01 9 5 37.59 centimeter. 37.59 centimeter. Approximately 37.6 centimeter. That is the radius of the circular patch. Right. Okay. Let's move to the other part of this question. What will happen to the diameter of the circular patch of light when another layer of water is placed on the glass plate? Briefly explain your answer. Briefly explain your answer. If you want, you can say it is it's like 37.6 kilogram පුළුවන්. Okay. 37.6, no problem. Because finite means you can take 37.6, no problem. So if you play another layer of water, what will happen? What will happen? Shall I erase the board? Shall I erase the board, Lamai? If you place another layer of water, what will happen? We will discuss that. Now again, we have water, which is 4 by 3. a water layer. A ray which is parallel to the interface now should be refract towards that. The reason is this is water, not air. The critical angle is not C now. Let's say it is refract to the water medium. When you do the refraction, if this is water, if this is glass block and it is water, remember if that is I, this must be I. Do you remember? If you have a glass plate, air, what will happen? I told you if it is I, this must be I. It must be parallel. Air, water or glass. The same concept can be applied. This must be parallel to that. This must be parallel to this. This must be parallel. The basic idea which we discussed earlier, it is I lemma. If that is I, this must be I, this must be I. If that is I, this must be the previous angle which is known as the critical angle earlier. That make I වෙනකොට make C වෙනවා. මොකද හේතුව ඔයාලට මතක ඇති මෙතන I නම් මේක I වෙන්න ඕන. මේක I වෙනකොට මේක I වෙන්න ඕනේ. මෙතන I වෙනකොට මෙයා C වෙන්න ඕනේ. Sorry, මෙතන I වෙනකොට මෙතන C වෙන්න ඕන. මෙතන I වෙනකොට මෙතන C වෙන්න ඕන. දැන් මේක ඔගේ concept එක තමයි ගන්න ඕනේ. මේක I නම් definitely this should be I. reason එක තමයි water. parallel වෙන්න ඕනේ මේ light rays දෙක. incident ray, emergent ray. මේ දෙක parallel වෙන්න ඕන. ඒ නිසා මේක I නම් මේක I වෙන්න ඕනේ. මේක I වෙනකොට ඉස්සලා අපි ඉගෙන ගත්තා මේක C වෙනවා කියලා. මේක C වෙනකොට මේක C. හැබැයි මතක තියාගන්න C කියලා කියන්නේ glass air interface එකට critical angle එක. It is not the glass water. Okay. I hope you would understand. Let's say this is the critical angle C dash for water air interface. Actually, if it is I, this must be not C dash, it should be I, based on the simple geometry. I don't know whether it is a critical angle or not. Without calculating that, we can't exactly tell. Let's say anyway, it is bends away from the normal. So what will happen? What happened here, according to the question what they asked? What will happen to the diameter of the circular patch of light when another layer of water is placed on the glass plate? They briefly explain your answer. The circular patch initially, that is R, but now it is more than R. It is more than R. The new circular patch is R dash. Why is that? When you place another layer of water, the light ray deviate more from the center of the circular patch. Neither from the center of the circular patch. So therefore we have large diameter now, large radius for the light patch. Understood? Okay there? Right. Can you please write that the answer? Please write the answer. When we place a water layer on top of glass, a light ray deviates more. A light ray deviates more from the center of the circular patch. From the center of the circular patch. Therefore, diameter of the circular patch increase. diameter of the circular patch increase. Diameter of the circular patch increase. Number 4, if the radius of the pond is 45 centimeter, it is 45 centimeter now. Calculate the minimum thickness of water layer need in 3 to make sure that the light patch covers the entire top surface. Now, let's say the thickness of the water layer is something like T. Something like T. Now it is completely covered means this must be 45 centimeter. Eh? This must be 45 centimeter. That must be 45 centimeter. We found the value of I. Let's say, what's the value of I? Can you tell me the value of my I? I value. If it is I, this must be I. If it is I, this is C. C. If it is C, this must be I. If it is I, this must be I. That's how it's going on. I kill the make a 90 but it can be, it is actually the margin. Entire surface of the pond is now covered with light. It is I. Minimum means I should consider this as the critical angle, but anyway, it's not required here. Can one of you tell me the value of I, which we calculated earlier? Yes, 48:35. I equal 48 degrees 35 minutes. Okay, 48 degrees and 35 minutes. Let's say this particular value, as I need you to draw this figure in your book, right? For every part, you have to draw this. Let's say x dash. R plus x dash. R plus x dash must be equal to 45 centimeter. R plus x dash equal to 45 centimeter. R plus x dash equal 45 centimeter. R plus x dash equal 45 centimeter. Okay. With that, we can find x dash first. So how to find x dash? How to find x dash? R equal 37.6 according to the previous calculation. So x dash equal 45 minus 37.6. 4 means 7.4 centimeter. X dash equal 7.4 centimeter. X dash equal 7.4 centimeter. If you know the x dash, we can calculate the thickness, the minimum thickness of the water column. Minimum thickness of the water column is taken as T dash or the T. So we can take tan I. Tan I equal x divided by T. T equal x divided by tan I. T equal x equal 7.4. Tan I, tan 48, 35. T equal how much then? Did we calculate tan 4835 earlier? Can one of you tell me the value? Tan 4835, 1.1363, ne? 7.4, 1.1363. Thickness, minimum thickness. How much is that? 6.5? 6.5 centimeters. It is the minimum thickness that you should place. So the entire surface is now covered. Entire surface is now covered. Okay, it's a good question. I think you can consider that again. So when you look at the questions, please look at that question again to get an idea. දැන් කෙනෙක්ට ප්‍රශ්නයක් වෙන්න පුළුවන් මෙතන I වෙන්නේ කොහොමද කියලා. ඉස්සෙල්ලත් අපි I ගත්තානේ කියලා. ඕව පොඩ්ඩක් ඔයා තනියම හිතන්න ඕන. මෙතන I වෙනවා, මෙතන I වෙනකොට මෙතන C වෙනවා. හැබැයි අපි දන්නවා මේක water, මේකත් water. Then both rays must be parallel to each other. ඔය concepts use කරලා තමයි මේක ගත්තේ. මේක ගත්තේ ඒකයි. ඒ concepts use කරලා. Okay there. Right, okay. We will move to another question. Question number 51. Question number 51 in your tutorial. Please read the question. Anyone who have completed 51? Anyone who have completed 51? Question number 51. Then bottom values change when නැති reason එක තමයි මම explain කළේ. Reason එක තමයි මේ light ray එක මෙයාට parallel වෙන්න ඕන. ඒක first condition එක. මෙතෙන්ට ගන්න පුළුවන් maximum value එක තමයි C කියලා අපිට ආවේ. ඒක මෙයාට critical angle එක නෙමෙයි. හැබැයි මෙයා C වෙන්නම ඕනේ. ඊට වඩා වැඩිපුර ගියොත් මේක cover කරගන්න බැරි වෙනවා. මෙතන C value එකට වඩා කෙනෙක් හිතුවොත් මේක වැඩි වෙන්න ඕනේ කියලා එතකොට මේ I කියන එක මැච් කරගන්න බැරි වෙනවා අපිට. මේක අපි හොයාගත්තේ මෙයා maximum නම් මෙයා ගන්න පුළුවන් maximum values දෙක තමයි මෙතන ගත්තේ. ඊට වඩා වැඩි වුණොත් අනිවාර්යයෙන්ම මේක පවත්වන්න බැරුව යනවා. bottom values වෙනස් වෙන්නේ නැහැ. ඒක නිසා තමයි මෙතන R කියලාම ගත්තේ. ඒක පොඩ්ඩක් හිතන්න මේක water ඔය concept දෙකත් එක තමයි ඕක වෙනස් වෙන්නේ නැත්තේ. Right, question number 51. Right, I'll give you 2-3 minutes. Can you start that question if you haven't done that? Question number 51. ඔය theory ඉගෙන ගන්නවත් එක්කම මේ questions වල අදහස ගන්න ඕන අනිවාර්යෙන්ම නැතිනම් කොච්චර අපි තේරුම් ගත්තත් question එකක් කරන්න බැරි නම් වැඩක් නැහැ. questions කීපයක් කරපුවාම හොඳ knowledge එකක් එනවා. දැන් මම අද කරන්නේ මේ part එක තමයි. අද අපි මේ sections කරලා ඉවර කරනවා. මේකේ presents වල questions තියෙනවා සහ theory part එකකුත් තියෙනවා. අපි ඒකත් කරන්නත් ඕන. Okay, let's move to question number 51. A monochromatic ray of light is falling with an angle of incident theta on a long glass block ABCD of refractive index n equal 1.6 placed in AR in the figure. Consider only the rays falling on the surface AB after the refraction at the surface AD in answering the following question. Disregard theta equals 0 situation. So they want us to get the rays only from AD surface. If it is go with the DC surfaces, those things are not accepted. They only want us to take the ray which is entered through AD surface. Find the critical angle for glass air interface. Okay, critical angle for glass air interface. Question number 51, part 1. Critical angle, let's say this is 90, then AR, this is glass. Sin C over sin 90 equal 1 into, it is N2 over N1. This is N1, this is N2. Sin C equal N2 is 1, N1 is given like 1.6 net, 1.6. So sin C equal 1 divided by 1.6. 1 divided by 1.6. Can one of you tell me the value? 1 divided by 1.6. 6250.6250. Then see what's the critical angle? 3841. Yes, exactly 3841. Right, check the others also, we get the same answers. You all get the same answer. Number 2. Show that the ray must undergo total internal reflection at the surface AB for all possible values of theta. This is AB. This is AD. Let's consider a particular ray which enter through AD surface. Now enter, refracted towards the normal. This is, let's say, theta. Let's say this is R. This is I. What we are trying to do, I'm trying to find the I minimum, right? If I minimum is greater than or equal to the critical angle, we can say it is total internal reflection always. Then method ray ek value එක මත R වෙනස් වෙනකොට I වෙනස් වෙනවා. Similar type of question I discussed last week also. I tried to find the minimum value of I minimum. We have an idea, I plus R equal 90 degrees, because this is 90. I minimum equal 90 minus R, or I equal 90 minus R. So I minimum equal 90 minus R maximum, isn't it? When R is maximum, I become minimum. Agreed? මේ logic එක ඔයාලට තේරෙන්න ඕන නැතිනම් බෑ වැඩේ කරන්න. දැන් මේ බක් වෙලාවට optics වල හරිම සරල sections එන්නේ පොඩ්ඩක් ඉතින් හිතන්න ඕනේ extra දෙයක්. I minimum equal 90 minus R maximum, because R maximum only we get the minimum value for I. I minimum equal R maximum. Right. Now, what is R maximum? R maximum is the critical angle here. It is the critical angle for glass air interface. R maximum, I just draw it, no need. R maximum is there when it is critical angle. When enter through the surface, it is a critical angle. Can it be more than C? No, it is impossible. R maximum is the critical angle for glass air interface. R maximum is the critical angle for glass air interface. Therefore, R maximum equal the critical angle equal 38 degrees 41 minutes. Therefore, I minimum equal 90 minus 38 41. Here 19 minutes 1 8 means 51 degrees. I minimum equal 51 degrees and 19 minutes. That tells us even the minimum angle, even the minimum angle is more than the critical angle. So what will happen? It never come to the air medium. What will happen? It always total internal reflection. You can say like this. Even the minimum value, minimum angle, I minimum is greater than. You can say I minimum is greater than the critical angle. What's the value of the critical angle? 38 and 41 minutes. For this is air, this is air, and this is glass. Critical angle. Therefore, total internal reflection for all possible values of theta. Understood? For all possible values of theta. When you write an answer, write it properly. Since these are essay type question, I need you to write like this. I minimum is greater than the critical angle. Therefore, total internal reflection for all possible values of theta at AB surface. Total internal reflection at AB for all possible values of theta. Okay, neither. Right? Finished? Shall I move to the next part? Right. Okay. When theta equal third මේ theta වල value එක මොකක් වුණත් මේ 0 කියන එක අපි ගන්නෙ නැහැ. 0 ගුවම AB surface එකට එන්නේ නැහැ. කෙලින් යන එකක් නේ. 0 ඇරෙන්නට අනිත් ඕනම එකකදී මෙතන total internal reflection එක වෙනවමයි. ඕනම එකකට theta වල. Right. When theta equal 30 degrees, calculate the angle of refraction at the surface AD. And then angle of incident at the surface AB. Right. I'll erase the board now. Right, now theta equal 30 degrees. Theta equals 30 degrees. If that is 30, we'll find the R, then we'll try to find the I. Sine 30 over sine R equal 1 and 2, which is air and glass. Refractive index of glass is given 1.6. Ne? Sine 30 sine R equal Ng over Na, Ng 1.6, this is 1. Sine R equal sine 30 half, this is 1.6. Sine R equal 0.5 over 1.6. R equal how much? What's the value of R? Anyone calculate it? Check whether you got the answer like 18 degrees, 13 minutes. Am I correct? Check whether the same answer you could obtain. Are any other? Right. 18 degrees and 13 minutes. Okay. Then we can say I plus R equal 90 degrees. So I equal 90 degrees minus 18, 13. Here 47, 1, 8 means 7. 71 degrees and 47 minutes. 71 and 47. Okay. Okay. Next one. Part 4. If the space above the surface AB is filled with the transparent material of refractive index 1.7, then draw the ray diagram after calculating the relevant angles for theta. If the space above the surface AB is filled with the transparent material of refractive index 1.7, now not here, it is now 1.7. 1.7. Calculate the relevant angles for theta. We take 30 degrees. Now it is not that, it is 1.7. Not here. Not here, right? Let's say a medium like N dash ANG. If it is 30, R won't change. R is fixed as earlier. R is 18.17. Even if the R is same, I won't change. I equals 71 degrees and 47 minutes. But you can understand this is dense medium compared with that. Why and how we know that? Refractive index of glass is 1.6. Refractive index of this particular medium is 1.7. Refractive, higher the refractive index, it is dense medium. So instead of bends away from the normal, it bends towards the normal. Bends towards the normal. No total internal reflection takes place here. Let's say this is I and this is something like R dash. Let's say R dash. Let's say R dash. We want to find R dash. But then make section එක ඉස්සලා කරපු ටිකම තමයි තියෙන්නේ. එතකොට මෙතන ඉඳලා පටන් ගන්න පුළුවන්. ඔයාලා ආයෙ මුල ඉඳලා පටන් ගත්තොත් exam එකේදී මේක 30 minutes වලින් කරන්න බෑ. පොඩක් හිතලම කරන්න ඕනේ. නේද? දැන් මේ section එක ඔයා කරනකොට මෙතන ඉඳලා පටන් ගන්න පුළුවන් ලේසියෙන්ම. Because 30 is not changed. If it is 30, R won't change. If R won't change, I won't change. ඉතින් මෙතනද පටන් ගන්න පුළුවන්. හරිම ලේසි එක හිතනවා නම් ළමයි පොඩ්ඩක් වෙනස් විදිහකට. Right. Now we can apply sin I over sin R dash equal glass N dash. I will take medium M1. So the M1 divided by Ng sin 71 47 sin R dash NM dash 1.7. This is 1.6. Sin R dash equal 1.6, 1.7 sin 71 degrees, 47 minutes. Sin R dash equal. Anyone who have calculated this? Point 9411 sin 71 degrees 47 minutes. R dash equal 63 23 minutes. Okay. I hope everyone got the answer. මට හිමීට කරන්නේ ඔයාලා මේක සේව් කරගන්න ඕන නිසා. Next part of this. If the space above the surface AB is filled with the transparent material of refractive index 1.5, find the maximum value of theta that the ray could undergo total internal reflection at AB. What happens if theta is greater than theta m? If the space above the surface AB is filled with the transparent material of refractive index 1.5, right? This is for the number 5 part A. Number 5 part A. Now it is 1.5. Refractive index is 1.5, the medium number 2. Let's say this is theta. Theta. If the space of the above surface AB is filled with a transparent material of refractive index 1.5, find the maximum value of theta that the ray could undergo total internal reflection at AB. From where we should understand, from where we should start. Theta is maximum when R is maximum. When R is maximum, I is minimum. I is minimum. Right? What is the minimum value of I so that total internal reflection could take place? Total internal reflection could take place. What is the minimum value of I? Minimum value එක මොකක්ද I වල total internal reflection එකක් වෙන්න පුළුවන්. දැන් මෙහෙමනේ ඔක පටන් ගන්න වෙන්නේ. Theta maximum means R maximum. When R maximum, I minimum. I should be minimum and I should develop the total internal reflection so that we confine to one location to find an answer. What is that answer? I should be what kind of value? Yes, exactly. It is the critical angle for these two medium. These two medium. Clear? Shall I write that as a part? The ඔයාලා මේව බලන්නේ ආයේ මාස 4කින් 5කින්. එතකොට පොඩ්ඩක් අපි මේක ලියලා තියාගමු. එතකොට ඔයාලට නැවත මේක යූස් කරගන්න පුළුවන් ලේසියෙන්ම. Theta, when theta maximum, R should be maximum. I need you to draw that, okay? I need you to draw that, otherwise pointers. When theta is maximum, R is maximum. When R maximum, I is minimum. I is minimum. Leave a line and write. I should be minimum. I should be minimum. And there should be total internal reflection. There should be total internal reflection at the AB surface. 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 To satisfy that criteria, we should select the critical angle for that interface. Let's take the critical angle as C dash. Let's take the critical angle as C dash. Sin C dash over sin 90 equal NG, or we can say glass N medium, NM over NG. Sin C dash equal sin 91, NM it is 1.5, NG it is 1.6. දැන් ඔය ළමයි පුරුදු වෙලා තියෙනවා මෙන්න මේ වගේ දෙයකට. කෙලින්ම sin C කියලා කියන්නේ 1 over n කියලා. ඒ එහෙම මත තියාගන්න එපා. ඒක ඔයාලට හරියන්නේ මොන ඉන්ස්ටන්ට් එකකට විතරද? Even the most of the teachers are asked them to remember like that. ඉතින් එහෙම කට්ටිය මේ වගේ තැනකට ආවම helpless. They don't know, they couldn't remember. They might know that but they couldn't remember. ඒ නිසා හැමදෙස්සම අර general equation එකකට යන්න. That is possible when this is air medium only. එයා එක නම් විතරයි ඒක ගැලපෙන්නේ. ඒක වෙනත් මීඩියම් එකක් කෙනෙකුට වෙනස් වෙනවා. ඉතින් මම මේක හැමදෙස්සම ලියන්නේ මම දන්නවා ළමයින්ගේ පැටර්න් එක මොකක්ද කියලා. ළමයින්ගේ පැටර්න් එක මේව මතක නැති වෙන ටයිම් එකත් එක්ක. ඒක නිසා we ask you to remember with the proper mechanism. ඒ නිසා පොඩ්ඩක් මේක වෙලාවක් කරගෙන ගියාට ඒක ඔයාලට පාඩුවක් වෙන්නේ නැහැ දරුවෝ. ඒ කියන්නේ ඔයා ඒක දෙයක් ඔයා තේරුම් ගන්නවා ඒකේ. ඒ නිසා මේක යූස් කරන්න හැමදෙස්සම ඉක්වේෂන් එකකට. හුඟක් ළමයි මේක ඔයා ක්වෙස්චන් එක කරනකම් ඔයාට ඕකේ. හැබැයි ඊට පස්සේ ඔයාලා මතක නැහැ. ඒක නිසා එහෙම කරන්න එපා. හරි ස්ටෙප්ස් වලට යන්න. Sin C dash equal 1.5 divided by 1.6. 9375. 0.9375. C dash equal. What is that value? Anyone know? Anyone of you calculate that? 6938. 6938. Okay, Nathan. I hope it is the answer. Okay, ne? Right. 6938 degrees. Right. Next one. C dash plus R must be equal to 90. R equal 90 degrees minus R equal 90 degrees. C dash 90, 69, 38. 22. 40, 22. Yes. This is 90. This is 0. 8 means 2. 20, 22. R equal 20, 22. 20, 22. Okay. R equal 20, 22. We have that answer. Then we want to find theta maximum. Sin theta m. Let's say theta m. Sin R. ANG. ANG. That is NG over NA. Sin theta m equal NG. NG, it is 1.6 NA1. NA1. Sin R, sin 20, 22. Can one of you tell me the sin 20, 22? Sin 20, 22. Can one of you tell me sin 20, 22? 0.348. 0.348. If it is the case, 0.348 multiplied by 1.6. 5568. 5568. Theta m. What's the value of theta m? Theta m. Any one of you? Check whether we get that 33 degrees 50 minutes. 33, okay, good. You got the 33, 50 minutes, right? Fine. Okay. Number B. An optical fiber is made, shown in the figure. You have the idea. What do you mean by? No, they asked another partner. What happens if theta is greater than theta m? If theta is greater than theta m, R is greater than the previous value. If R is that value, this particular angle is less than the critical angle. Am I correct? Theta කියන එක දැන් ඔය calculate කරපු 33 degrees 50 minutes වලට වැඩි වුණොත් R maximum වෙනවා ඊට වඩා R වැඩි වෙනවා ඊට වඩා ඉස්සෙල්ලා වැඩි R වැඩි වෙනකොට මේක C dash වලට අඩු වෙනවා. What will happen? It is refracted to the next media. Shall you write that? If theta is greater than theta m, if theta is greater than theta m, if theta is greater than theta m, the incident angle for AB interface, the incident angle for AB interface is less than the critical angle. Less than the critical angle. Therefore, that particular ray is refracted at AB surface, AB interface, refracted at AB interface. Right, next point. An optical fiber is made, shown in the figure. A monochromatic ray of light enter a fiber from here at an angle theta which is slightly less than theta m. Now, if I take that is theta m, it is less than theta m. If it is less than theta m, r is less than that value. It is more than the critical angle, total internal reflection. That is our point. Okay. Slightly less than theta m. Draw the path of the ray in fiber. Optical fiber communication. I told you a few things related to that last week under the application. So they asked us to draw that. So when you draw that, we can use something like this AB surface. This is the incident angle, total internal reflection. That is enough. This is n equal 1.5 ne. This is n equal 1.6. This is what we call the cladding. This is core and that is cladding. Always draw the arrowhead. 58, okay. Sorry, 51, okay. So I prefer to do the question number 52 also. Question number 52. Question number 52. I'll give you few minutes to do this question. Anyone who have done this question number 52? Any one of you? Right, shall we start? Question number 52, why in the 52? Right, figure 1 shows a monochromatic ray. Monochromatic ray means a single colored ray. Ray of light entering a spherical raindrop at A and emerging from C after single refraction at point P. If the refractive index of water is 4/3, calculate the critical angle for water-air interface. 53, part A. This is air and this is water. Refractive index of water is given. It is 4/3. Critical angle sin C over sin 90 equal 1 into NW over NAR. Divided by 1. NW, it is 4/3. Sorry, it is NA over NW. This is A, this is WNA. 1 divided by 4/3. So sin C equal 3/4. Sin C equal 3/4. Then sin C equal 0.75. C equal how much? Anyone calculated that? C equal how much? What's the value of C? 48 degrees 6 minutes. This is the answer. Right. It's given neither. It's given in the answer also. Number B. Giving reason, show that the ray of light can never be totally internally reflected from the opposite surface of the raindrop for any angle of incident I. Let's say this is R. This is R. This is I and this is R. If that is R, this must be R. If that is R, this must be R. Number B, part 1. A, B. To observe the total internal reflection, R must be greater than or equal to critical angle. What they ask from us? Giving reason, show that the ray of light never be totally internal reflected from the opposite surface of the raindrop for any angle of incident I. Methane total internal reflection කවදාවත් වෙන්නේ නැහැ කියලා පෙන්නන්නලු. How to show that? To have a total internal reflection, R must be greater than or equal to critical angle. That is the point that you should write. For the total internal reflection, for the total internal, please write like this, okay? For the total internal reflection at B, incident angle, which is R, must be greater than the critical angle. For the total internal reflection at B, incident angle must be greater than the critical angle. Okay? If that is here, if that is greater than or equal to the critical, if that is greater than the critical angle, This must be greater than or equal to the critical angle. Can it be greater than the critical angle? Can it be greater than the critical angle? It is impossible. Reason is, if that is greater than the critical angle, this must be greater than the critical angle. This must be more than 90, which is impossible. Then make a critical angle like a winne. Make a critical angle like a winne. Eka instant take a tadi. May rake a 90 in no. Edakada may a critical angle like a winne. May a critical angle. A velavata metana C venava. Idi A instant take arranged when instant take up now. Okay. When instant එකක් නැද මේක total internal reflection එක වෙන්න නම් අනිවාර්යෙන්ම r කියන එක more than the critical angle. ඉතින් r කියන එකට critical angle එකකට වඩා වැඩි එකක් ගන්න බෑ. A කියන location එකේදී. ඒකෝන මේ වගේ දෙයක් වෙන්න බෑ. Did you get my point? Did you get the idea? Clear the right. Shall we write that part? You write up to this location. It is not A, it is P. According to that, it is P. Right under that. If the ray suffer total internal reflection at P, if the ray suffer total internal reflection at P, incident angle at P within bracket simple r, incident angle at P within bracket simple r should be greater than the critical angle, should be greater than the critical angle, should be greater than the critical angle. Should be greater than the critical angle. If this happen, refracted angle at A, at point A, refracted angle at point A, refracted angle at point A. The reason is these lengths are equal radius, ne? Refracted angle at point A, refracted angle at point A should be greater than the critical angle, should be greater than the critical angle. This is impossible. This is impossible. This is impossible. This is impossible. And the refracted angle at point A, as the refracted angle at point A cannot be more than the critical angle, cannot be more than the critical angle. මේකට කවදාවත් critical angle එකට වඩා වැඩි වෙන්න බෑ. හේතුව තමයි මේක critical angle එකට 90 වෙනවා මෙතන. ඉතින් 90 වලට වඩා වැඩි එක්කෙනෙක් නැහැ නේ මෙතන. 90 වලට වඩා incident angle එක වැඩි වෙන්න බෑ. Okay නේද? Clear? Right. Next point, number C, part 1. Write down an expression for the angle of deviation of the ray due to the refraction at A in terms of I and R. I and R. Okay. So now you want to assume this kind of ray is there. This kind of ray is there and answer these questions. Number C, part 1. Location A. This is taken as I. This is taken as R. If that is R, this must be R. If that is R, it's given as R. If that is R, this must be I. Why is that? Reversibility of light. Anyway, it is given. No need to think on that. This ray supposed to travel along this line, but now it is deviated. Let's say it is D1. So they want us to calculate the angle of deviation at point A. D1 equal I minus R. I minus R. Number 2. Write down the expression. I go with the direction. Write down the expression for the angle of deviation of the ray AP due to the refraction at P in terms of R. This ray supposed to travel along this line. Now it is deviated. Now it is D2. D2 equal total angle is 180 minus 2R. 180 minus 2R. This is number 3. Write down an expression for the angle of deviation of the ray PC. PC. This is P net. This is C. PC. Due to the refraction at C in terms of I and R. Now it is taken. It is taken at this point. It is D3. 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 This angle is R. This is total angle is I minus R. I minus R. Number 4. Number 4. Number 4. Hence, write down an expression for the total angle of deviation D of the emergent ray related to the incident ray in terms of I and R. Total angle of deviation in that direction equal D1, D2 plus D3. D1 plus D2 plus D3. All are in the same direction. Capital D equal I minus R plus 180 minus 2R. 2R plus I minus R. 180 minus or the plus 2I minus 4R. D equal that value. If that is in opposite way, I should take minus here. Remember those things. In a day, they would ask like that. Remember like that. Okay. Number D. No, a raindrop, a rainbow can be seen due to the emergence of incident sunlight from raindrops. Since sunlight consists of all visible colors, figure 2 shows such refracted red and blue color ray. Copy the figure into your answer sheet and complete the subsequent path of the red and blue rays. Shall I remove this one? Shall I erase this? Okay, I'll use this phrase. Let's say location D here. Location D. This is the white color. White color. It's striped with the red and blue. This is red. If that is blue, that is blue. That is your observation, eh? So this is the way that you should draw that. Anyway, the main requirement, this blue ray should be above the red color one. That is the main requirement, but I try to draw in a proper way. That's why it takes certain time. Okay. So if somebody look at through this location, he would see the rainbow, blue, yellow, like that, up to the red. Okay, there. Right. Next one. The expression obtained in C part 4 above show that D vary with I. It has been found that when I equal 52 degrees, the blue ray emerge for the rainbow with an angle of minimum deviation. Angle of minimum deviation. Angle of minimum deviation. When the blue ray, when I equal 52, the blue ray emerge for the raindrop with the angle of minimum deviation. Determine the corresponding angle of minimum deviation for the blue ray. D equal 180 plus 2I minus 4R. So now the incident is 52. This is minimum when I equal 52 degrees. So don't confuse with the minimum deviation for the prism section. It is not relevant to that, but anyway, they have given the minimum angle of deviation when I equal 52 for blue ray. 180 minus 2 plus 2I minus 4R. They ask us to find the minimum near raindrop with the angle of minimum deviation. They ask us to find the minimum deviation, D minimum. To find the D minimum, I should find the R value. If it is 52 degrees, let's say R is the value at that point. So let's apply the Snell's law for the blue ray. Find 52 degrees divided by sin R equal ANG, AN water, N water divided by NA. Sin R over sin 52 equal NA NW. Sin R equal NA1 NW. NW, what's the value? NW, it's given 4 by 3. 4 divided by 3 sin 52. Sin R equal sin 52 3 by 4. Sin 52 is given 0.788. 0.788. Sin R. What's the value of this? .591. R equal how much there? Any one of you? Any one of you? Check whether it is 36, 25 minutes. 36, 10 minutes. 10. Okay, 36, 10 minutes. Right. Now we have the value for the D minimum. D minimum equal 180 plus 2I 52 degrees for 36, 10 minutes. D minimum 182, 80 plus 104 minus 4 into 36, that is 40 minutes. That is 24. 4 into 3, that is 12, 14. 144, 72, 144, right? This is 4, 8, 284, 144, 40 minutes. What is that? It is 20 minutes. This is how much? This is 9, 7, that is 3, 139, 139 degrees and 20 minutes. It is something like that. If a blue ray, actually it is a white color one, if a blue ray is there, finally it is deviated like that. If I extend this line, this is what they mention as deviation angle, D minimum. Understood? D minimum is how much? 139, 20 minutes. Is that clear? Okay, there. Okay, the 139 20 minute. Yes, if you are getting a wrong expression for the day minimum, everything goes wrong. It depends on the situation. Sometimes they would allocate a few marks based on the way that you have reached the answer, but most of the time after that location you are not getting any mark. So that's why they ask one step by step the answers. Ne? Islam method location deviation, this point, and total. So you should get the proper answer all the time, then you lose marks. Right. Okay. With that, there is another part. Neither. Assume, okay, the light ray, assume I equal 52 in your ray diagram drawn in D above, mark D minimum. They want us to mark D minimum. Can I erase the board? Can I erase the board? Right. I try to mark the D minimum value. This is the blue ray. It make a product smart pen or නැත්නම් වැඩි යන්නේ නැහැ ඉස්සරහට පොඩ්ඩක් angle එකක් දාලා ඇඳ ගන්න නැත්නම් ඒක D minimum එක ගන්න බෑ. This is D minimum. දැන් මේ රේක යන්න හිටියේ මේ track එකේ නේ. දැන් හැබැයි යන්නේ මේ track එකේ. ඉතින් දැන් මම ඉස්සෙල්ලා අඳපු විදිහට මේ දෙකම parallel කවදාවත් ඔහොම එකක් ගන්න බැරි. පොඩ්ඩක් මම smart වුණා මෙන්න මේ විදිහට ඇඳා. මේ race exactly අපිට අඳින්න බෑ කොහොමත් මොකද මේවා angles equal වෙන විදිහට approximately ඇඳලා තියෙන්නේ. ඒ නිසා අපිට මේක අඳින්න බෑ practically. But anyway in a question like this you want to be smart. So you should draw with an angle like this. Otherwise you are not getting the things ne? D minimum. Okay නේද? Right. The light of any color that emerge from the raindrop with the angle of minimum deviation corresponding to that color is especially bright as rays bunch up that angle. These bright color band which are deviated with the minimum angle of deviation enter the eye of an observer on the ground and thereby rainbow is seen. So you have the blue color one. So you have a red color one like that. This is red and this is blue. This is red, this is blue. Determine the angle made by blue ray of the rainbow with the horizontal related to the observer on the ground. So this is the observer on the ground, okay? This is the horizontal direction. This is the horizontal direction. What is this angle? This is that angle, ne? What is that angle? Use the number. What is that angle? For the part 3, that angle equal 180 degrees minus D minimum. 180 degrees minus 139 20 minute. What is that? 40 minute 100, that is 40. Is that 40? Yes, 40, ne? 40 degrees and 40 minutes. Okay, the